Well, hello humans. Alright, what we have in front of us is chapter 5.2b. This is attached to our packet, our new packet for this semester. So we're going to start with polynomial long division, and what we're really doing is applying brute force to figure out whether or not something is a factor of a quadratic or any polynomial. So in this case, x plus 5, what I'm really asking here is x equal -5? Is this an answer so I can unlock this quadratic that's right here, this 4x squared plus 23x minus 16? So that being said, we are going to use long division, something like this. So how many times does 324 get divided by 8? Well, 8 times 4 is 32. We're going to subtract those, and we get 0. We're going to drag down this 4. Well, unfortunately, 8 doesn't go into 4, not nicely. So we have to say that it goes in 0 times, and we got to drag down. We got to put in a decimal point. So this is what old-timey, beautiful long division looked like. And this is what we ended up with. We always want to end up with a remainder of 0, so r of 0. We want to end up with a remainder of 0, which is really, really important because that's going to play a part in what we're doing here today. We are going to now use long division to divide into a polynomial. And what we're really trying to do is match values and multiply, just like we did in long division of the past. So let's try it. We're going to divide this first term of the dividend by the first term in the divisor. So we're going to set this up. X plus 5 is going to divide 4x squared plus 23x minus 16. So now I am going to see what multiplies to x to make 4x squared. And I think for this one, if we're thinking about this, I'm going to need to use a 4x to multiply the 4x, or the x plus 5. I'm going to do that over here. I'm going to do 4x times x plus 5 and see what occurs. So I'm going to use some distribution. I end up with 4x squared plus 20x. And I'm going to put that right underneath our 4x squared plus 23. So here's 4x squared plus 20x. Now, in long division, we will use subtraction. But in this case, we are going to add the opposites. So I am going to add the opposites, and I'll highlight that in red. So here you go. These are now opposites. So I'm going to add the opposites here, and I'm going to add them down or subtract, ideally. So I have no more x squareds, but I end up having 3 x's. And if you get confused here, go back 20 seconds, rewatch what I just did. Instead of subtracting, I'm adding the opposite. But now I'm going to keep with my long division ways, and I'm going to drag down what's left. So now I need to match my x with this 3x. So that means I need to multiply. The x plus 5. So here we go. I need to multiply this x plus 5 to match this 3x by a positive 3. So I am going to multiply it by positive 3. And I'm going to distribute again. And I end up with 3x plus 15. 3x plus 15. And like I said before, we are going to subtract, but that really means we are going to add the opposite. So this is minus, and that's a negative, or minus, minus. And I am going to add the opposites down. So I have no more x's, which is good. I didn't want that. But I'm going to end up with -31 as a remainder. And so I've done all of this. I've got down here, and I have a remainder of -31. That's a bummer. That means x plus 5 is not a factor of the quadratic 4x squared plus 23x minus 16. So here's my final solution. 4x plus 3 is what I used, and I'll highlight that right here. And I have a remainder of 31 with a remainder of -31. Sorry, remainder of -31. But let's try this next one right here. Let's try this practice problem. I bet this one will be a little bit smoother. So we're going to try to take x minus 7 and divide it into 3x squared minus 29x plus 56. So let's see how this goes. I need to multiply this x to match this 3x squared. And the only way I do that is if I multiply everything by a 3x. So I'm going to take 3x times x minus 7, and I'm going to distribute it, and I should end up with 3x squared minus 21x. So 3x squared minus 21x. I am going to add the opposites, so the 3x squared becomes negative and the 21 becomes positive, and I'm going to add down. No more x squareds, but I end up with negative 8x plus 56 after I drag it down. So now I need to match my x with this negative 8x. So I am going to have to multiply the x by a negative 8. I'm going to have to multiply by negative 8. So I have a negative 8 times x minus 7, because that's my factor, that I'm hoping will fit, hoping it'll work. It'll be the key to unlock this door. I'm going to distribute it. So I have a negative 8x plus a 56. Ooh, they match. Negative 8x plus 56. I'm going to add the opposites. So this becomes a plus. This one becomes a minus. That goes away. Oh, they all go away, and I have a remainder of 0. So what does this mean? If the remainder is a 0, if the remainder is a 0, then the divisor is a factor of the polynomial. So what this states right here is 3x squared minus 29x plus 56 is x minus 7. I'll highlight that. X minus 7 because, whoopsie daisy, because this did work. It worked and worked well. Times the quantity of 3x. 3x minus 8. That means they're factors. And that's all we're really doing today. All we're going to do is utilize long division to see whether or not a factor works. And if it does work, that means that we can keep on going further and further and further until we unlock the entire polynomial or the quadratic. So your test is right here. Try this x minus 5 or x to the 5th minus 32 and see if x minus 2 is a factor. But I will give you one clue. Here is how you set this up. If we're missing terms, you must supplement them with 0 of the missing terms. You cannot do it any other way. Notice I have x to the 5th, then 0x to the 4th, then 0x to the 3rd, then 0x squared, then 0x minus 32. Give this one a try. Come visit me in class if you'd like to see the answer for this one. Thank you for your time.